In this video clip, I'm going to solve the mystery of DNA bases. I told you that non-covalent bonding is important to solve the mystery. The non-covalent bonding between elements can be thought of in terms of lab and like. To simplify, the lab can be defined as being attracted to dissimilar things. The like is defined as being attracted to similar things. The men and women are attracted to each other because they are different from each other. That is love, in my definition. On the other hand, the people who share the similar values are also often attracted to each other and may form a friendship. That is like, in my definition. The people often have a mixture of love and like for human bonding. Through love and like, they are sometimes attracted and sometimes separated. The non-covalent bonding is something like that. Like humans, some compounds are attracted to each other and form non-covalent bonds. The non-covalent bonds, which can be separated or combined, are extremely important to the structure of DNA and proteins it encodes. There are two types of non-covalent bonds that occur in DNA or protein structures. One has the characteristics of lab, and the other has the characteristics of like. In chemistry, the concept of like is easy to understand. For example, when oil and water are mixed, here's water. Then if you put oil in there, what's going to happen? The droplets of oil aggregates and avoid the droplets of water. So the hydrophobic or oily materials get together. This non-covalent bonding of oily materials is called hydrophobic interaction, which is similar to the concept of like. This type of bonding is important to the structure of proteins and their interaction with drugs because drugs are hydrophobic. What about the lab? Look at this one. So this diagram shows a schematic diagram of three water molecules. H2O. We have three of them here. Note that the bonds shown by red, red dashed lines, these. These bonds are characteristic of love. What do I mean by that? In general, nitrogen and oxygen atoms strongly attract electrons. In this case, oxygen attract the electron and try to suck electrons from the atoms adjacent to them. This is why the hydrogen atom near nitrogen or oxygen are slightly positively charged. Slightly positively charged. Right? Then on the other hand, nitrogen and oxygen are slightly negatively charged. Negatively charged. right here. Then, because they suck electron from a hydrogen atom, and because they have a pair of their own lone pair electrons that do not form a bond. So when an electron-deficient hydrogen atom and electron-rich nitrogen or oxygen atom are attracted to each other, hydrogen bonding occurs. So this is just water. How about typical hydrogen bonds in human body? So here I show 3 typical hydrogen bonding interactions in a body. So then they all look similar to you actually, because you saw the structure of DNA bases. So here, right here, as I mentioned, oxygen and nitrogen are negatively charged because they suck electron from the adjacent atoms. So these. The hydrogen adjacent to them are positively charged. So then, positively charged hydrogen and negatively charged oxygen are attracted with each other. So this is hydrogen bonding interaction. In this case, negatively charged nitrogen and positively charged hydrogen are attracted to each other. That's hydrogen bond too. So they all look familiar to you, as I mentioned. These functional groups are found in DNA-based structures. So DNA contains many hydrogen bonds. So this diagram shows the bonding in the DNA base pairs AT and GC. Note the hydrogen bonds here. These hydrogen bonds. So GC base pair has 3, AT base pair has 2. So that's why GC base pairs have are roughly 50% more stable than AT base pairs. Then based on this structure, we can see why the numbers of G's and C's and the numbers of A's and T's would be almost the same as Dr. Chagov described. If he had known or deciphered the structure of DNA, he might have shared the Nobel Prize in chemistry, but unfortunately he did not. As I tell you briefly in the next video clip, Dr. Watson and Dr. Crick did.